Okay, for people who are joining this live stream, this is part of a long series of efforts to make the material from my book, A New Kind of Science, to be computable in notebooks. And I was just looking at how far I've got in doing this. So there's just lots and lots of pictures and pages and so on, all these kinds of lovely things. And they were all created like 20 years ago or more. And the code basically still runs, but I'm trying to clean it up and make it so it's minimal and easy to reproduce. So the first thing I'm going to do is I was just looking at what I had already done on doing this. There are a total of 973 pictures in the book, and I believe I have done about 86 of those so far. But the first thing I'm going to do here is start cleaning up what I've done, and I have it's very kind of basic, but I have a directory structure and so on. Oh, that's not very good. There's nothing listed as finished there. Okay, so there's a bunch of unfinished ones there. So I'm putting in these directories, finished and unfinished. So I'm going to start with chapter 2 here, section 1. And I was doing this in a different way before. So this was done as ongoing. So I want to actually make this as a finished and unfinished section in here. So I'm going to go ahead and do that. I'm going to make a finished section. And I'm going to start off here. This looks to be a fine thing on page 24. So I will just go ahead and make that a separate notebook here. This is a bit clerical, what I'm going to be doing initially, but hopefully we will get to new stuff very quickly. So this is, so sometimes here I'm going to want to, okay, that's all good. Sometimes I'm going to want to put things like this into our new function repository, but let's go ahead and let's just see, is there more stuff on page 24? Doesn't look like it. Is that 24? Let's see, page 24. Oh yeah, there is. Okay, so now I want to go in here, section 1, finished, page -24A. Okay, and then I'm going to go over here, super simple. And this is going to be, again, this is all very easy for right now. Page 24B. Okay. This is really easy. Okay. Again, this is going to speed up probably pretty quickly. Oh, we got a bunch to do here. I wonder if I should write code to do this. Let me see. I could do that. It's probably just not worth the trouble. I think I should just do this by hand. Okay. This is 25A. I think that it's going to get more complicated in a few moments here. Maybe if I've done enough of these, I will go ahead and do something slightly different. Okay, well, I've got 973 of these pictures to do all together, and obviously, and as I said, I've only done 86 of them at this level. Okay, 25C. Okay, now this one, that next one, 25D. Okay. Now the next one, unfortunately, is unfinished. So let me put that. Now I'm going to go up a level, make a directory called unfinished. And that is page, what was that? That was page 26. All right, I admit this is getting kind of boring, but all right, this is along with every exciting thing one does, there's a certain amount of boring stuff. So let's just go and try and get through this boring stuff. That is page 27A. I'm going to skip to doing something else after I get through this section. Page 27B. Page 29. Oh yeah, this is fun. This was page 30, which had rule 30 on it in the book. So at least I know what that page number is without even looking it up. Okay, page 32A. Page 32B. Oh, this is a complicated case. That is complicated. That is pages, multiple pages altogether. Okay, so I don't think I have a way to code that yet. So that will be page dash 32. 32, is that right? Page 32 through 37. Now, hopefully that won't mess up the beautiful system we have for doing these. Okay, and that one is page 38. And then I'm going to stop doing this and go back to doing something a little bit more creative here. Okay, so that's the ongoing file. I can now delete that. That is that ongoing file there. Let me go ahead and move that to the trash. Okay, all right. All right, well then let me keep going here and let's go on to a section that I haven't done. So let's look at chapter 3, see what I've done on chapter 3. Chapter 3, what's happened there? Oh gosh, there's all kinds of stuff there, but it isn't in quite the right format, but I'm not going to worry about that. Okay, this is what I haven't done. Chapter 3, section 3. Okay, so let's just take a look at what's in chapter 3, section 3. And let's go there, chapter 3, section 3, mobile automata. Oh yeah, these are fun. Okay, so this is now the old code. Oh great, that is code that's not very useful. It's a huge mess there. Okay, this is code from the book, and unfortunately we don't have the initialization file here, but I'm going to go find it. That uses these functions that actually I would like to put in the function repository that do, okay, so let's go ahead and do some of that. It's going to be a little tricky, but all right, let's try doing some of this. This won't be super fast, but let's do it anyway. Okay, let's go back to book construction notebooks, chapter 3, section 3, and now I'm going to pull up the actual original code from a long time ago. Okay, so that mobile automata /ma.m, and that will be in the book construction programs. Okay, book construction programs. Where is that? Mobile automata / that's interesting. Book construction notebooks. Well, let's see, where are they? So that is a all right, so let's take a look here. So I have to find mobile automata /MA. Let's go look. That's a bit odd that that's not in my programs directory. Maybe I am misremembering this. Well, let's try utilities. That's interesting. Those utilities are probably look at all those things like tuples and min positions and so on, and mail run. Oh wow, that was early stuff for doing code. Okay, so let me just take a look here. Why? Notes programs? No. Book construction notebooks. Let's see. That is very odd. Okay, you know what I'm going to do? I'm actually going to look at the raw file system that has these things on it. So let me take a look there. This is an old file system. So let's take a look here. This is book. So I'm thinking it's in book layout. And wonder if it's in notebooks. Probably not. So then, humpty humph. Let's look under programs. Oh, there's tons of programs here. Why are these not available? Oh, well, this is going to be where it is. There's the program. ma.nb, May 14th, 1999. That was when it was last accessed. Okay, that's kind of annoying. Let me just see. Okay, that is annoying. I am going to start this copying over because I need to get all of these in there. I'm simply going to copy everything in there, and I'm going to say move it to book construction notebooks. And it says preparing to copy like thousands and thousands of items. And I think it's going to do that, but let's go back over here and just get going on what we're doing here. Oh, actually, that's not going to do the right thing. That's not going to do the right thing. I am going to rename that. Hold on 1 second. I am going to start the copy of just everything that's here. Arguably, I should just do this with okay, let's just close this up. Let me copy these all over. Okay, it's copying thousands of files here, 4,000 files. Okay, well, I did a lot of work in 10 years on this book, so there it is. Okay, let's go open this up. Okay, so I don't want to, I am going to try to write, okay, so there is, wow, oh, look at these. These are all files from 1992. So that's when I originally worked on Mobile Automata, was 1992. And this looks like it's a file from a generalized mobile automaton. Let's just take a look at that one. And this looks like it's a file from a 2D mobile automaton. Okay. All right, let me go ahead and do the following. Let me start Let me start seeing what I'm going to do with these. So what I'm going to basically do is I'm going to make a file. Oh, wow, there are 8,000 items. My gosh, there are a lot of files here. Okay, so this is going to be a function repository item, and it's going to be something that I call mobile automaton. So let me go ahead and name that right now. Function repository pending mobile automaton. So this wants to be analogous to our cellular automaton function. And then I'm probably going to want a mobile automaton plot as well. But okay, let us take a look at what we've got here. Rules are specified by triple arrow new value move. Machine state is tape, comma, position. Okay, so let's see what happens with Turing machine and how this is analogous to Turing machine or not. Okay, Turing machine. I see, with an initial tape of 4 ones. Wow, my copy may or may not have succeeded here. Oh boy, copying these files failed because of an incompatibility between the Mac file system and an old file system that I used to have. So that's kind of annoying. So I'm pretty sure that what I should do then, that's really pretty brain dead of the Mac OS. Okay, let me see. Yeah, we have a copy directory, and let's see what it does. Copies the directory. Does it do it recursively? Doesn't seem to. I'm actually surprised there isn't a recursive option for this. Okay, let's try to do this. Okay, so Turing machines have a representation here that says, okay, so it's rule, init, and time. Yeah, this may take a while to do. Let me see. Replacements of the form state, and then the tape goes to that. Okay, so let's take a look. Machine state is tape arrow position. Okay. State of the head, value of the cell under the head. Okay. Rules are from triple goes to new value and then a move. Okay. Okay, fine. Okay. All right. Why is these different? MMA step. That's MMA is a different kind of thing. That's a generalized mobile automaton. Oh, that's one which has more than one head, I think. Oh, wow, what a complicated thing here. Oh dear. Okay, this may not be a good thing for me to work on right now. You know what? I'm gonna punt on this, and I'm gonna work on a different section. Right. Let's go work on a nice fresh section that should be pretty easy. Let's go work how about we try some chapter 6? So let's take a look. Chapter 6. All right, that looks dead easy. So let's go to chapter 6, section 1. Okay, hold on here. Chapter 6, section 1. Chapter 6, section 1, source file. Okay. Okay, there we go. Oh, wow, that's actually got, I see. So I've actually seeded the random number generator there in a specific way. Well, I'm not sure I'm going to be able to reproduce that, but hopefully that won't be necessary. Let's take a look here. So that is rule 254. Okay, so let's try and reproduce this at least. So it would be, I wonder what seed random list does. Let's take a look here. That should be, oh drat. I have to go back to the original construction notebooks, section 6, 1, init. Okay. So this is probably loading. What is that doing? Why is that different? Oh, no, it isn't different. Okay. Okay, I think what I want to do there is to just say, I think that 0.3 is probably the density of black cells. So what I want to do is I want to say random, let's first of all just do this for the simple case. Okay, so let's just say random integer 1, 90, and then let's say cellular automaton 254, that, 15. That's the number of steps, and then say array plot that, mesh arrow true. Okay, now apart from the fact that the mesh looks really stupid at this magnification, but that's just a feature of a small bug. It won't look stupid if I go to 100%. Right, so unfortunately, okay, well, let's just go to 100% for right now. Okay, now we want to make this not, so I'm gonna go ahead and put that in here. This is chapter 6, section 1, and this is page 224A. Okay, and let's go ahead and say finished, because I think we're going to be able to do this for this one. Finished. Page, what was it again? 224A. Okay, so now here, this actually is not right because we want to actually do random choice. And we want to say for random choice, we want to weight it by the weights. Okay, so we want to say weights 0.3, 0.7 in favor of like that, and then 90 of those. Okay, so that's what we're doing there. Okay, great. Okay, and now the only other thing we have to do here is a rule plot of cellular automaton 254. that was that rule there. And I think what we could do is to say, I don't know whether we want to mess around and really combine those in the same graphic. I think that's a little bit unnecessary. We could say graphics row of %65, comma %64. I don't think that's going to look quite right because it's going to make that bigger. Yeah, we have to do a bunch of messing around there. I think this is good enough. I think this is what the useful part of that has been captured. Okay, so that's page 224A. Maybe I should put this as a labeled thing. Let's do this, and let's see whether the label maybe has an option to put it off to one side. Okay. It's kind of annoying that we have to do that. Let's just take a look here. Label may have a placement option. Oh yeah. Position specified by pause. Left, okay. There we go. It's pretty much what we need. Now, it's kind of weird that you can resize those independently, but I guess that's okay. All right, that's 224A. All right, so let's go ahead and do the other ones here. Yes. Yeah, it's different from what's on the page because we've got different random numbers here, and I'm not trying to reproduce the random seeding. I mean, I could. I'm going to make myself a little to-do thing. Page 224. Not reproducing the seed random. I think that may be hard to do. We'll have to go back to a legacy version of the random number generator and all kinds of weird things like that. Okay, but let's maintain that. All right, so now let's go ahead for the other ones on this page. Let's see what there is there. Okay, so this is 224A. So now let's go back to 224B. Oh, wow, what on earth is that? Seed random list 655. What on earth is this? That must be the positioning. Oh, that's the precise positioning. Okay, so those are the rule numbers there. And let's go ahead and make another one here. This is this. And then what we want to say here is that, hash that, hash that. And then we want to do this. And then we want to just say column. Here, see what that does. Okay, well, okay, so that is the wrong. Okay, so what we actually want is just random integer here. It's kind of annoying that this is small like that. I wonder what happens if we just say graphics column. That looks awful. What did that do? That's just totally stupid. That is just dumb what that does. Let's see. I am going to send that in as something that shouldn't work that way. But okay, so if we did column there, we will get a result. But unfortunately, those things are not very good in terms of sizing. I mean, we could go ahead and say here, image size arrow large, but I hate to do that. And there we could also say image size large. That's not a good idea. Image size medium. I don't consider this terrific. Let's see how that compares with what's on the page, though. Yeah, I mean, but for the round numbers, it's pretty much the same. Again, I'm going to leave this in this form because I think it's can worry about that later. I'm mostly trying to get a lot of coverage here. 224B, and I'm going to note that in the to-do file. 224A, 224B. Okay, that's an issue with sizing there. Okay, let's go on to the next page. Oh, come on, there's more of the same. It's kind of dull. And the fact that those things happen to be on the right-hand side is definitely not profound here. All right, let's keep going. Oh, hold on 1 second. Let me check something here. So in this, we said, oh, that was only 10 steps. Let's go back here. Oh, yeah, that's right. It's only 10 steps. I goofed that. Okay. Yeah, let's see what happens if I just leave that out there. Oh, that's way too small. Oh, dear. And well, let's see if I say image size to small. No. But if I say medium, it's already too big. And I could give an explicit size. Let's not worry about that right now. Okay, instead, let's go on to 225. And for 225, we're going to need the same thing. And just for the heck of it, we can put that on the right. And 225. 24 steps. This. Okay, let's see what that looks like. Okay, well, apart from the fact that those things are too big, which I think is, again, not a problem we're going to solve right now, that was page 225. $226 should be very, very easy. That one should be like super easy. He says, famous last words, page 226. Okay, that's just array plot rule 126. And then that is 400 across and 440 down. And there's no mesh on it, and there's no image size. Okay, that was easy. And now we've also got to say, this has gotten a lot easier in the last 25 years. Then we've just got to say rule plot of that. Okay, and that's page 226. Okay. Oh, come on. These are not difficult. Okay, 227. Okay. I told you these ones will be easier. 227, they're kind of boring though. 227, oh, interesting. We're getting a window on that page. I don't know whether that's icy because we don't want them to wrap around from one side to the other. So we actually need to do that as in array plot, cellular automaton of hash of random integer 1, 800. And then I want to say 350 steps. And then I want to say in that cellular automaton, actually, I want to say 350 steps. And then I want to say from, for some bizarre reason, that's 330 there, but I don't know why I compute 350 steps. And then only, okay, so it's minus 150 to 150. Let's see what that does. That may fail horribly, but let's try it. Okay, that's on rules 22, 30, etc. Let's see what that does. Okay, looks promising. So now let's go ahead and I wonder if we want to just do I could just label this. Let's label it on the array plot. And we want to say frame label arrow string template and then rule check that string template of that. Now I suspect if I do that, well, it's amusing, but definitely not right. Okay, wrong place. So I think I want to say none, comma that. Oops. And we seem to have something that looks reasonably right. Yes, let me go to 150% magnification. My apologies. I'm just okay. That is that. Now we can get very, very detailed about what we do on that page, but I think this is basically what we want. We could just make these, I guess, large just for I don't know really what I should be doing with the large, etc. Oh no, that's silly. Yeah, I think that's kind of silly. Let's not do that. Let's just leave them at natural size. Okay, so that is now page 227. Okay, let's move on. Oh, come on. Okay. 228. What on earth is that? Wait a minute, that's 228. What page is this? This is 228. Why does that have all that weird stuff on it? Let's take a look here. Oh, wow. Okay, that was mislabeled. So that was 228. Did this get goofed up? Oh my gosh. Hopeless. Okay, I'm going to go back over here. this was done wrong. Okay. Okay, let me go back to the original files from the book. And let me then find this from those original files. This was chapter 6, section 1. Wow, where are they? Interesting. Oh, wait a minute. That's class 3.eps. This page, page 228, appears to be missing. How could that be? Where are those? How are those files generated? Well, that's definitely odd. Well, humph. Well, it looks like these were the same, although I have to say I can't actually give evidence of that here. 126, 440. Okay, there's those ones. Wow, they're missing. Well, who knows? Okay, well, let's get them right now. Okay, so then we basically want 228 there is rule 90 and rule 105. Rule 90, rule 105. Okay, and that was page 228. Okay, page 229. This is going to be complicated. Well, unless continuation of that. Okay. Okay, well, I'm going to do both of them together then. Now this has some very elaborate, what on earth is that? Rectify. What on earth is that? I don't understand that at all. That's some weird thing with some postscript. I don't understand that at all. Huh. Funky. Okay, so that's a seeded list, and then that's the same thing, but it keeps going. Huh, I really don't understand that. All right, well, let's put this one in. So this is okay, so that doesn't have a label there, so it's just array plot of that, and I don't think we have to do any of that fancy stuff there. Yeah, actually, the one thing we do have to do is to say that's 110, and then this is 600, and then we're going 700 steps, but actually we want steps, and then we want to break it in two. So that wants to be 1400 steps there. And instead of a single array plot there, we want to map array plot over partition this in 700s. Okay, so I reckon that should do the right thing. Okay, there we go. They're a little small, but that's what we get here. Okay, that looks good. Okay, so that is page 229 through 230. Okay. Oh boy. This is again not the most exciting page. These are a bunch of really boring pages. Okay. Well, we should be able to do them fast. Okay. Here, let's use that template there. So this is now the next section. 227. Let's go. This is that source. We want to go to section 2 there. Oh, I'm just going to ignore the newer stuff and I'm just going to use my original one. Okay, so those are the rules there. And that's what it says. It's class whatever. So let's just pull these in and 300, 130. Okay. All right. So this is now page 231. Okay, let's go look at this here. Okay. Actually, I want to just go ahead, chapter 6, section 2, and this is going to be the finished folder. And this is page 231. Okay, so now here we are going to give, okay, so what we want to do here is we want to say #1 for that, and we want to say #2 for this, and then we want to say here 250, comma, class 1, 108, class 2, 126, class 3, and now that totalistic rule, I believe, would be it's rule 52. I think that's right. I think I just have to do that. Let's find out. Class 4. Let's just see what happens if I do that. Oops, I don't do that. And this is, yeah, that there is at of those. Okay, so I probably got something wrong with that last one. So I want to check the cellular automaton function and make sure I know what I'm doing here. So K, 1, R. There we go. Okay. And now let me just check what the actual size of those things was, because I don't think I had this right. That was 300 across and 130 down and minus 75 to 75 to get that region in there. Okay. There we have it. Okay. All right, let's keep going here. Okay, next up we have this big array. see whether we can get that whole array in there. So that, what on earth is all this? Oh, legal rules, is that match? What is this doing? 0, 4, oh, youch. Okay. Okay. We have to do the same thing. Okay, well, we can do exactly this. We can just go ahead and do that. So this is page. So this is getting rules that have the appropriate properties. Page 232. Yeah, there we go. That's those. Now, isn't it amazing how this code all just works after so many years? And now we've got that same thing there, and again, we've got right, actually here we have this thing. It'll be more like this. Okay, so now we've got these ones are 160. I don't know why it's 160 there. It doesn't need to be 160. Well, it's 52, so it's 104 there. 104 across there. And then it is 60, 52, 52. And now it's those. And then it is mapping that across this. And then there, after we get that, it is partitioning those in groups of 4. And it's then saying graphics grid of that. See what happens there. There we go. Okay. Looks lovely, except I'm a little bit surprised. These look a little wider than those ones. So let's just check this carefully. 0 to 60 minus 52 to 52. Yeah, looks right. Looks right. Don't these look wider? Don't these ones here look wider than these? That's really odd. Window is 0 to 60 down and minus 52 to 52. I'm suspicious something is wrong here. Anyway, we can save this away as page 232. But I'm a little suspicious about that. It doesn't look quite right. Again, what could possibly have gone wrong here? So that is 160. That's definitely not right. So, well, let me just see what happens if I say 160 there, although I don't really see why that should make any difference at all. No, it doesn't. Humph. Okay, well, I'm a little confused by that. Maybe there's more space there or something? I'm not sure. Okay, I want to put that back to 104 because I think that's more correct. Okay. Okay, let's move on to the next page. Okay, that has the same parameters, and that is range 0 to 63 in steps of 2. Okay, so let's go do that. Okay. Okay, so for this, we are the rule number, This is a 2, 1, 2. And this is 0 to 63 in steps of 2. If I wanted to, I could make that a table, but I don't think there's a reason to do that. Partition that, in groups of 4. And then we need the graphics grid, and let's see what that does. Okay. So something goofed up there. Code 0 to 63. Oh, well, that's because I said 53 there. That's why that won't be right. And I want to say code instead of rule. Yeah, I agree. The mathematical musings are saying looks like the aspect ratio is off. I agree with that. I wonder what on earth is happening here. I wonder if what's happening, all those pixels seem square. I don't know. I need to mark this down as a to-do item. Something is definitely a little wrong here. I mean, I'm wondering if maybe what's happening is that graphics grid. Well, let's see what happens if I do this. Let's see. On this page 233. Let's see what happens if I just take one of these and do it without its labels. Oh dear, something is very, very wrong. Something is very wrong with the way those labels are working. Oh dear. All right, just a minute. I'm going to send this in. This is a bug of some kind. Okay, I think this is something where it's probably just going to work. I mean, I think this is just a bug. So, humph. Well, okay, let's keep going, even though this is definitely slightly wrong. I think this may be a bug in my version 12 that I'm running right now because things are being worked on with respect to labels like this. So let's keep going. Oh boy. Okay. Okay, this is page 234. Okay. So this should be, there's the rules, and that's a 3-1. Yeah, the aspect ratios look way wrong. And these rules look wrong. So there's, oh, that's what's wrong. Important change there. Actually, I don't need that. Those were the wrong class of rules because these were second nearest neighbor there. Okay, this looks right. Okay. Now again, aspect ratio is looking wrong, but I think that's going to get fixed. Okay, 234. Oh boy, well, this is beautiful. I don't think I even need the rule number written down there. I think we just need those images. Oh, there's a whole bunch of these. I wonder what Gen Big does. I wonder whether that's up there. Gen Big. Oh, there's an important bug we just introduced here. Those are not initial conditions of just one. They're initial conditions that go up to 3. Okay. So this should be, that's interesting. That doesn't, okay, so now, yes, so Gen Big steps 1490. And that says Gen Big 7861. What does the 7861 do? Oh boy, that's a seed. Okay, so that's 1490 steps. Okay, 1200 across. And 1490 steps. And it appears to not be trying to avoid wraparound there, so that's okay. So then this is 1815. And that's the thing. There it is. Okay. Boy, it's gotten a lot easier to do these things in the intervening years here. Okay. Page 236. Okay. Okay, we got 237, 238, 239. Okay. Okay, that was 1815. Oh, 2007. That's one I've been using recently. That's a lovely rule. Okay. So that is page, oops, we need to go back here. Make sure we get it right. Page 237. Oops. And then we want that to be 2007. Boom. There you go. And let's see, that was page 237, page 238. One 659. It is nice being able to just type in these programs sort of by numbers like this. I mean, that's because these are such simple programs. You just get to give just a simple number, and that specifies everything. Okay, that is 2043, 239. Page 243. No, 239. Okay. Okay, let's keep going here. Oh boy, there's some other ones here. Okay, so let's see what's next. Okay. Those are slightly weirder cases. What's coming up next? Oh wow, all kinds of stuff. Okay. So let's look at these borderline cases. Why are those so complicated? Okay. Right. So we need to do that with this template here. Okay. So these are 3-1 rules, and that's the right thing there. 104, 60. That's right. And now we've got these particular rule numbers are. It might be faster to just type them in than to mess around. Okay, 219, 438, 1380. I recognize that one. So, and 1632. I recognize that one as well. Okay, great. Okay, that is page 240. Okay, let's keep going. Okay, this is a big, complicated collection of these things. Oh, so that's actually fairly straightforward. That's the same deal as on a lot of these other pages, except that those are now. Okay. Okay, that's interesting. This is. Okay, interesting. All right, so let's do this. Let's say this thing. Okay, that is 4,1 there. And this is. Oh, let me just check something here. Yep, that's right. And that becomes 3,104. And now this is mapping this over this slightly wild. Oh, I see what that's doing. Okay, all right, okay. Okay. This number here. I mean, that's a slightly wacky way to do this, but I guess it's as reasonable as any. No, that's a silly way to do it. Let's just do 0 and then that plus this number here. Why is it confused? That should just give us that sequence of numbers. Okay, that's the mapping. Oh, this. Oh, I see. We don't need one of those. Okay, let's try this. Well, that wasn't so magnificent, was it? Okay, what did we do wrong? Why is this taking so long? Okay, that's reasonable. Okay, that looks right. 080106. Yeah, looks right. Okay, that is page 241. Okay. How can this be page 243? What's going on there? Really? Wow. Okay, well, fine. Those are continuous cellular automata. I'm really surprised I talked about those in this section. Okay, well, maybe I did. I didn't remember that. Okay, CML evolve list. Okay, so this is a function. Okay, that's interesting. So those are numbers between. Okay, well, this is good. Okay, let's write this. This is going to be a continuous cellular automaton. So for that, we want to say it's going to be kind of the same deal as this, except a bunch of things are going to be different. Okay, so here we do want to have this thing called C, and we want to say table of the array plot of that, comma, and then C is going from 0 to 0.9 and steps of 0.1, and then the partition is comma 2, and then the grid. Okay, that's fine, but there's going to be a lot more stuff here to actually make this work. Okay, so that is page 243. I do not remember this page in the NKS book. That's a shocker. Okay, so now I have to look up Cellular Automaton because it has a way of doing functions, and the rule there, Boolean function, there we go, RSpec. Okay, so that's a function, and the RSpec is 1 there because it's nearest neighbor, and this here is mod. Okay, let's see what happens here. Actually, I could say fractional part here, but let's just do this for now. Do I really want to live this dangerously? Let's see, that is a random number, so that's random real. Random real 1, 170, and that's going to be 70 steps. I can't believe I should really do this way. Hold on, that's a pure function there. Come on, I'm not going to be this bold. I'm just going to try one. I'm going to say with C equals 0.5, let's say, then this thing. Come on, wake up, do your thing. That is slow. That's really slow. What is it doing? I am suspicious here. All right, let's try a much smaller one. Let's say 20 and then 10 steps. Goes out of range there. Okay, well, this is the same as fractional part. Wonder what I say there for what it says it does. Averaging the gray levels of its two neighbors. Oh. In this case, I'm doing the wrong thing. Okay. To each list of neighbors. Yeah. That's not right. Okay, so this is fractional part of hash plus C, but then I want to say mean of hash plus C. There we go. Yeah, that was doing some crazy computation before. Amazing. What do you know? That's magnificent. Okay, that's got that page. Great. That was easy. Okay, Okay, now what about this one next? Let's see how that one works. Let's see, I've not been paying attention here. Let's see. Let me see. What am I doing here? So this is the next one is abs differences. The heck is this? I think, what is the description of what this is doing? Rules the same, gray level, each neighboring cell is multiplied by 1.13 before the average is done. Addition, the actual gray levels in these pictures are obtained by taking the difference between the gray level of each cell and its neighbor, thus removing. Rules are the same kind as in the previous picture, except that in the third case shown here. Oh, I see. Each neighboring cell is multiplied by 1.13. Okay, all right, fine. Okay, so then what we're going to do here is, this is page 244. We are going to, that's a bug that thing doesn't show up as the full percentage there. This is what I get. I'm running the very latest version. Let's see what version I'm running. Pre-release version 12, built November 17th. Oh, it's 3 days old. My gosh. Shocking. Okay, 244, page 244. Okay, so now that is 0.398, I think it says there. Yeah, let's just check what this is doing. Okay. So let's go ahead and make those functions, make those functions be what we're mapping over here. Yeah, let's do this. That's 0.398. And it's going to matter that this is 398 over 1,000. It's going to matter that that's an exact number, I think. So that's that function. The next one is 0.4. And the next one says each neighboring cell is multiplied by 1.13 before the average is done. So I'm thinking that means that it's okay, that's 0.5, so that's plus a half. And each neighboring cell is multiplied by 1.13. So that becomes 0.5, 1.13. I don't know why I chose 1.13, but then those are the rules. And now what I want to do is I want to say it's that #1 there and #2 here. And then I want to do take that and I want to map it over these. And this is going to be full of stripes. So let's go ahead and wonder what happens if I just say, let's see, this says abs differences. So I think what I want to do here is I want to say differences / at that. And then I want to say abs of the whole thing. See what that does. Let's live dangerously and just try running it. Wow. Did something reasonable. Okay, let's see what these look like. It's a bit coarse here. Why is it so coarse? Probably because the parameters are totally different here. That was 580 steps by 200. Okay, 580 by 200. It's taking its time. Oh, beautiful. Oh, magnificent. Isn't it amazing how you do these experiments again 25 years later and they give the same answers? Well, except that one didn't. Possibly because the gray level of each neighboring cell, I think that is, let's take a look here. CML function. What the heck is that? 0.565 there. Times 2 is 1.13. Each neighboring cell is multiplied by that. So I think I have to find CML evolve list and see whether I can figure out what this is doing. Yeah, why is it 1.13? I have no idea, but because I obviously studied, I was trying to get a marginal case. This is essentially a phase transition between two different kinds of behavior, and I suspect 1.13 was right at the edge. You know what? Maybe there's a note. Implementation of continuous cellular automata, that's an encouraging sign. Page 158, it is fractional part plus a quarter, and that's not useful there. Okay, that's a nice implementation method for these, but although we're now using the built-in thing. Okay, what's going on here? Well, my best guess, let's just take a look at CML evolve list. I think if we're lucky, it's in there. No, it's not. Okay, let me go look for CML evolve list. Hold on. I have to go find. Let me see here. Let's see. Does this load a package at the beginning? Does not. Let's see. Wonder whether it's in here. Nope. All right, I am officially a little bit confused here. Let's take a look. That is, let me find continuous programs. I wonder where this is. Maybe it's under utilities. Don't think so. All right, let me look here. These are all the programs back from like 1998, etc. I wonder if it's in diagrams. Don't think so. Why that was in 2003, I have no idea. Why that was updated. The book was finished in 2002. So where would these continuous functions be? Maybe numerical systems. How about that? CML.nb. What do you know? There it is. CML evolve list. Okay. CML evolve step. Okay. So what this wants to look for. There we go. There's the factor. Prefactor is only next to those, the neighboring cells, not the cell itself. Okay, so what we want to do there is we want to say, okay, so the 1.13, well, we could do it this way. We could just say that 1, comma 1.13. It will be somewhat clear what's going on. Let's try running it again. Let's see if this is reasonable. Well, that's beautiful, but it's not right. Okay, let's just look at this again. Humph. Okay. Okay, let's look at the formula here. B plus G. Well, let's try 0.565 there. I don't think that's different from what it says in the text. Oh boy, I believe the text is wrong. I believe we found a bug in the text. That's interesting. So, I mean, the 1.13 is, so I think that's actually something I should probably make a note there. Should probably add an erratum. The gray level of each neighboring cell. Yeah, I think that's not right. Okay, so let me just make a note of that. Let's see, page 244. Wow, there are not very many errata in this book. Let's see, erratum multiplied by 1.13 should be multiply by 0.565. Now, maybe that piece of text is misunderstood here, but that's okay. That's great. That's cool. Okay. Let's keep going. Wow, this is a super long section. Crazy long section. I don't remember this section being anything like this long. Oh, wow, it's going to get onto the game of life and everything here. Okay, well, fine, cool. Okay, I see. This shows different steps in the evolution according to one particular rule. Okay, so great, let's do it. Okay, well, I'm glad I'm doing this section. This section is it's useful. Okay. All right, so this is now somebody's asking, okay, we'll take a micro break here. Somebody's asking, are there fundamental connections between NKS and deep neural networks, since both attempt to seek useful programs in the computational universe? Yes, there definitely are. In fact, I talked about that in a blog post I wrote a couple of years ago at the 15th anniversary of NKS. Essentially, what's the only difference really is that neural networks, well, they tend to have continuous parameters, at least right now, which means that you can use calculus to use essentially gradient descent to fit the behavior of the system to what you want to have happen. In things like cellular automata, it's you have to have kind of fuzzy criteria for fitting. And then right now, the best we know is to just do big exhaustive searches across large spaces of rules. My guess is that there is an incremental way to do that, but we haven't found it yet. And my guess is that if one understood more about the geometry of cellular automaton rules space, one would know how to do that. And it's a project that I hope to work on one of these days. All right, let me try. Okay, these are totalistic 5 rules. So these are cellular automaton. Now I wonder if I should just use, I think I might just want to use, for clarity, I might just want to use let's do that. Let's use the association form of this. So totalistic code, arrow. Let's do the very first one here. What is that one? That one is rule 4. Totalistic code 4. Well, let's say dimension is 2. Colors is 2, but that's the default. Neighborhood is 5. And then we're going to start this off for an initial condition, which is 60 by 60. So random integer 1, 60 by 60. And then I want to say evolve that for 500 steps. But actually what I want to do, I wonder if there's a way to do that here, to sample it every some number of steps. Let's take a look here. T1, T2, DT. Step T alone. Wonder if I can do that for multiple steps. Let's take a look. Let's say step 3 alone, step 5 alone. What happens if I do that? And then let's say I map array plot across that. That was not successful. Okay, so let's say I just say step 5 alone. Magnificent. Okay, so now the issue is going to be that I need to have the same initial condition here. So I'm probably going to have to do the following. I'm probably going to have to actually evolve it for 500 steps. And then what I'm going to have to do is I'm going to say this thing, and then I'm going to say that sub, and then I'm going to say 1, 2, 5, 100, 500. Let's see what that does. Okay, great. So now I'm going to have to label those, and we may have the same horrifying labeling bug that we had before. Oh, I see. So that's going to have to say step, whatever it is. So let's say frame, arrow, none, comma, string template of step, backtick, comma, hash, and then, oops, that's not what I want to do. Let's see, of hash there, and then I want to do that. That's that. Humph. Actually, what I want to do there is this. I want to say with let's say evolution equals this. Make an array plot with this. Yes, this subhash, that array plot there, map that over those, and close the with. Oh, what did I goof up here? Okay, the array plot. That's the array plot. Oh, silly me. Wow, that's weird. It doesn't even give a color there. Okay. What did I do wrong here? Frame. Oh, frame label. That's what I want to say. There we go. Okay. And then what I want to say is graphics row of that. Okay. It's got this crazy distortion, which we don't understand. And then what we want to say is labeled that, comma, and that's we're going to say this is a function of rule number, let's say code C. And that is going to go in there to the C to C there. And this is going to say String template. That's going to say code C. And now that's that function. So close that function /at. And now we've got this series of rules, which we give in here. And let's see what happens if we do this. And then we probably want to make a column out of that, but let's worry about that in a moment. And that's going to be page 246. Yeah, I think that looks pretty good. Lovely. Wait a minute, step 200? No, I meant step, oh, I screwed this up. Okay, so that should have been step 100 there. Oh well, I have to regenerate it. Okay, so apart from these weird distortions, which are some kind of temporary bug, that's looking good. Okay. Oh, another one of these. What are those? Oh, patterns. Okay. All right. So that's then just 500 steps. Okay. So that's page 247. Okay. So here we are going to do this with okay, that it's going to say array plot of that. It's going to say frame label of that. It's going to say 500 steps. And it needs a first in there because it's going to give a list of things. And it's going to say it's not step, but it's code. And this is going to say that's code there. And this is then going to do that. And then it's going to be, well, let's see, what are these things? Those are, 2 to 16 steps of 2. Well, I could as well say table. And then I could say C for code there. And then I would say code 2 to 60 in steps of 2. And then I'm doing a partition by 5. And then I'm doing graphics array. Partition that by 5 and a graphics array. And let's see what that produces. Oh, I mean graphics grid, silly me. Okay, many, many different problems here. Okay, graphics grid. Okay, what am I doing wrong here? What did I goof up? Totalistic code. Humph. Looks like they're all the same rule there. And what did I do wrong? Okay, let's try this for a particular one of these. Like code 6, which seems to have a lovely maze pattern. Okay, what's happening here? Dimension 2. What's happening here? Okay, let's take a look at the Cellular Automaton function. Let's look at scope. Let's look at multidimensional rules. Oh. Why do I have to do that? That is because I am trying to get... I'm a little confused by that, but let's try this. Wait a minute. Position 1. Is not a list of rules. Oh, that's because I don't need the first there. Now, if I do that, there we go. Okay, I goofed this up because I was using, okay. Get rid of the first, because that is actually pulling out that element there. And now let's try this. Wake up, wake up. Okay, that's a good sign. Okay, let's compare with what we had before. Looks encouraging. We happen to get a different phase over there, but that looks right. Okay, that was page 247. Okay, let's keep going. Oh boy. Okay. These are slices. So I think we should be able to get that pretty easily with the same technology. Okay. So let's go ahead and try and get a slice here. There's a bunch of tricky things going on here. So this is a slice looking down. So it's a two-dimensional rule, and we're looking into the page. Okay, let's take a look here. I think the Cellular Automaton function shows how to do some of those. Let's see. Let's try applications. I have no idea if that will have it. Oh, yeah. Okay, that says mean. Okay, so we have to look at how this works. Okay, slices. Oh, wow. Okay, slice image array. Okay. That's going to awful lot of trouble to do this, but I wonder what slice image array does. Oh, look at that. There's a gamma value. -1 hash minus plus depth. Okay, so what that's doing is as it goes into the page, it's showing, it's having it be progressively lighter as it's going to the page. That's an interesting general function, actually. Okay. All right, so first of all, let's get these rules. So let's say it's rule 52, just for the sake of having one to look at. And let's take a look at the parameters that we're using here. GE1. Profoundly. Okay, it took 109 seconds back in the day. Make slice 220. Wonder what that 0.6 is. Okay, we got to look at make slice here. Where is make slice? Oh, I mean CA 2D. Okay, All right, let's take a look at what's going on here. So depth is min of 256, comma, steps. Well, that's steps. So I'm kind of thinking that's 100 steps there. Yeah, I bet this one shows a larger number of steps. That's 280 steps there. Okay, so I'm thinking that there is a 220 there. I'm thinking that that becomes 220. And that is now no, that doesn't seem right. I wonder if that's 100 there. Oh no, that's the slice position. That's the slice position. And then this is 280. Okay, now how do you make a slice? So what you do is over here, what is this doing? Mean slash at. Well, let's just see what happens if we just do that. This isn't going to be the correct slicing, but let's say mean slash at this. Okay, good. So that's not completely crazy. 248. So what that's doing is it's making something where you're looking down into the fog, and you're just seeing you're seeing the thing. Yeah, you're not seeing the thing with a decaying fog, if you understand what I'm saying. You're seeing the thing with every value. Okay, so what this is doing, so some of these here, this minus gamma. Okay, CA real 1 minus gamma to the power minus hash plus depth plus 1. Okay, so that appears to be the way that it tries to do as it goes deeper into the thing. Okay, so that slice thing. Okay, CA, where does it make use of the slice? Okay, that is the fifth argument there. 1, 2, 3, 4, 5. Okay, so gamma in this world is 0.6. And the depth is the min of 256 and steps. So I think what this means is that the thing is multiplying by, okay, 1 minus 0.6 to the power minus, well, let's say k. So then let's see what that is. Table of that, k goes up to 10. That is a crazy number. That is a totally crazy number. Oh, plus depth. So let's see what that would do. So plus depth, if depth is like 256, plus 1, who knows what that is, minus k plus depth. Okay. Well, let's see what happens if we go to 200 there. Okay, am I doing something really stupid here? Minus 0.6. Let's see, we go to 500. Oh yeah, okay. I don't think this is right though, because this is saying gamma to the power What this is doing is it's going. Okay, let's take a look at what this looks like in. Okay, the full thing here, which we can get by doing image 3D. Okay, that's the full thing with image 3D. Now, I can change the transfer function here. Gosh, I don't really know what I'm doing here, but let's imagine I do that. What on earth is that doing? Okay, so let's say apply that. Help, why is it flashing like that? It's not a good sign. Didn't do very much. So this is the 3D, this is seeing into the fog, so to speak. And what we want to do, okay, let's try to get, so this thing is a 220 by 220 by 280 array. Oh, what is this doing? Okay, so let's make a much smaller version of this so we can see what's going on. Let's make a 5 by 5 by 10 array. Okay, there we go. So now, if we were to say mean slash at that, what is that even doing? That is somehow, okay, so hold on. This is the dimensions of that array, 142, are 11 by 5 by 5. And the dimensions of 143 are 11 by 5. Okay, so mean got rid of the lowest dimension. That's exactly the right thing for it to do in order to look through the fog at that lowest dimension. So, well, the lowest dimension here is, yeah, okay, so we want to combine those things at the lowest dimension. So that means that what we want to do is to map. Okay, so a simple-minded thing to do here will be to map map indexed something to the power minus map indexed hash. Well, let's just say 2 to the minus last of hash 2 onto that at level minus 2, I claim. Okay, so that will do that. That's the right thing there. And then we have to do mean slash at that. Bluff, bluff. That's not right. Maybe that's to the minus 1 there. Yeah, okay, now we say mean slash at that. Okay, that's right. That's what we want to do. So let's try it again up here. So this wants to say map indexed of that. I think we can just say 2 point to the power minus last. That will make it a little faster, I think. Now, after this thing, we want to say comma list minus 1, close. My gosh, why is this taking so much forever? Oh, probably because those numbers are getting huge. No, come on. Okay, so if let's do it for a slightly smaller case. We just do it for 22, 22, 22, 28. That doesn't look totally convincing. Let's do 5, 5, 10. Okay, I don't believe that. Okay, so then what's happening here? So this is mapping onto the lowest level Okay, well, one trivial thing we want to do is that's a one index thing, so it wants to say 1 minus that, but I don't think that's going to make much difference. Okay, that's level 1 there. And then here, okay, let me see up again here what this is doing. So this seems to be map thread max. Okay, well, why don't we just take this code, see what happens. Boy, it's amazing. That code must have been written like 20 years ago, 25 years ago. It's still just fine. Still got the map indexed. #1 times map thread that. Boy, I do not get what that is doing. So I think what we want to do is make, okay, so again, what I've got, wait a second. Oh, unbelievable silliness. Unbelievable silliness. Yes, in fact, it's exactly what the old code there did. Okay. That times #1, because we've actually got to, okay, this is much better. I don't know why it's so slow. Kill it. Okay. But this is at least, let's try this. Okay, that's not quite right, but it's not as obviously stupid as before. What does this look like? I think we maybe have to do a transpose in here. I'm just going to guess here that we transpose levels 2 and 3, but that might be completely wrong. Actually, it's not completely wrong. Okay. Okay, now the problem is, why is this so slow? Well, should we try doing something modern? Let's try doing function compile of function. And then let's say typed x, comma, real 32 is going to be enough, I think, comma, typed y, integer 32, comma, and then we want to say x times 2 point to the power minus Y. Okay, let's try that. All right, so now we compile that to machine code. Oh, wow. That's rather disappointing. Wonder what that is doing. Again, interesting. Well, okay. All right, we could use the old-fashioned compiler. Not a satisfiable candidate for that type conversion. Okay. Well, let's see. What can we do here? So let's try making that a bit bigger. So let's say times 4 times 2. Oh, something's starting to work there. Well, let's try this one then. 220, 280. Let's just see whether that just works. Maybe it was doing something completely crazy before. Why is this taking so long? Well, I wonder what happens if we don't go that deep. I mean, I don't think it needs to be that deep. Let's say we only go 40 deep there. Why is this? Oh, there we go. That is nice. That is very nice. Yeah, beautiful. Now that's 2 as the thing that gives depth. I wonder whether what the gamma of 0.6 was. I wonder what 1 over 0.6 would be. That would be 1.6. So let's say, gosh, I'm so incompetent here. Let's try 5/3. Okay. Let's see what this looks like with 5/3 instead of 2. We could pre-compute those things, but I don't think it's really worth it. Let's try 1.6 there. Hardly any visible difference, but let's use that one. Okay. Okay, so what we've got here, all right, I think we can do it. So on this page, we have 4, 12, 24, 38. And I've got previous cases, frame label. And that is hash there. And this is hash here. And this is, let's take a look here, 4, 12, 24, 38. And on the top of that page, it is where does it say how many steps that is? Steps. Oh, 100 there, as opposed to 280. Okay, so I think what we want to do here, let's do 100 steps there. And then we want to do 280 steps of 30 and 52. Okay, magnificent. Okay, now I suppose we could do something where we actually make it look precisely like on the page, but I don't think it's worth the trouble of making it. Yeah, I don't think it's important to do that. Well, actually, this is going to do it, but this is just for this notebook width, so it's not really a real thing. I wonder if we want to. No, I think this is fine. Okay. Now I want to basically have yes. Let's see, depth faded, array plot, 3D. Okay. All right. Oh boy. All right, there's 2 more pictures in this section, and then I gotta go. Let's see if we can just do the 2 more pictures. Those are both Game of Life, I think. So here, boy, complicated. Okay. Okay. All right, I think we can do these. That first one, so this is page 249. Oops. Okay. So I think we actually have a Game of Life function. Let's see if anything like that works. What do you know? Magnificent. Okay, except that I think those parameters aren't really quite right for this. Okay, so let's try here. Let's just see what the parameters are here. Wow, complicated. Okay. 350 by 600. So this is with depth 40 there, which may not be enough. It's taking its time. Okay, well, that's dandy, but I think depth 40 isn't enough. I think that's the problem we're seeing here. So let's try depth 100, which is going to take it a while. That's, the Game of Life seen into a, yeah, it's also possible that that parameter isn't really very good. Let's take a look there. 0.93 is the gamma there. So that is compared to up here, that 0.93 is to be compared to 0.6 there. Okay, let's take a look at what this looks like. That didn't work either. So, okay, so 0.93 means have it decay more slowly. So that means that should be closer to 1. So 0.93, let's look at what's 1 over 0.93. 1.07. Let's see what happens if we do that. Well, that's better, but I don't know why it isn't darker than that. It could be that we're actually artificially darkening. Okay, so let's think about that for a second. The minimum value there. Oh, hold on. I bet this is wrong. I bet this is an off by 1 error. Oh, that won't make much difference because 10 to the 1.07 times 10 to the power minus that. Well, let's just try like 0.03 there. I don't think that's going to work. Okay, so this is up to 1,000 steps, but that's 0.97 humph. Okay, because that has to take a certain number of steps beyond this. Yeah, this isn't quite right. This is okay, so that's not quite right. Hold on, let's just try and do the other one for a second. Okay, so there we want the thing to go 1,000 steps. Well, let's just say 200 steps there. And then from step 200, we want to say reverse, and then we want to say take, well, then we want to say for those, we want to try doing this. Map indexed over that. Yeah, I think so. Then we just want to say, let's see, then we want to just, okay, that's going to give us, yeah, we need to know how big those are. 200, I think. Those are 200 by 200, but I'm not going to do that case yet. And those are, I'm going to do a much smaller case. I'm going to do 20 by 20 and 20 steps. Okay, now Okay, fine. So then what I want to do is I want to say, what happens if I just say mean of that whole thing? And then I say array plot. Hard to know exactly what that means, but let's try it up here. Mean of that. Array plots of that. Aha, look at that. Isn't that lovely? That is quite lovely. Okay, so that's going to be, so let's try, again, for some reason, these aren't quite as dark as these ones, and we need to solve that problem. But this is, okay, so 200, 500, 1,000. So this is 200 to 500. All right, let's try that. All right, let's take a look at this. Well, that's basically right. I mean, unfortunately, I didn't have any gliders there, but that can happen. Okay. Okay. Well, I think it's time to wrap up, but I'm pretty happy with this. Let's see, page 249. Let's just try one more thing here to make these darker. I wonder why this is. See, what is happening here is that the maximum value. Let's just look at this. Let's say 200. And let's just say the max of everything in there. That's really weird. Well, I wonder what would happen if we said, take this and divide by, so for each one of these, do hash divided by max of hash. What would that do? Why didn't that do anything? Oh, it did. Oh, I see. I see. It did the right thing here. It just is making the thing decay. Well, let's just see what happens if we do something like that. Doesn't really make any difference. I am a little confused. Well, actually, what happens if we just say, if I just said 1 there, then this would just make a total mess, I think. Yeah. Right, then it doesn't show, then it shows kind of clouds everywhere. Okay, so there's some slight glitch there. All right, well, thanks for joining me. This is We got almost a whole. Look at that. We got chapter 6. The whole first section is now done. Actually, first 2 sections are now done. So it's a long way. Good stuff. All right. Thank you all, and bye.